We are introducing here normal forms and their conversions. We will discuss here introduction to context-free grammar, application of context-free grammar, normal forms in which CNF and GNF, the next conversion of CFG into CNF and conversion of CFG into GNF both, and then at last the application of normal forms. A context-free grammar is a notation for describing languages. Context-free grammar derive their name from the fact that the substitution of variable on the left of a production can be made at any time such a variable appears in sentential form. A context-free grammar is a four-tuple VTSP where V is a finite set called the variables, T is a finite set disjoint from V called the terminal, P is a finite set of rules with each rule being a variable and a string of variables and terminals, and S that belongs to V is the start variable. A grammar is said to be context-free if all production in P are of the form that A derives X, where A belongs to V, that is variable, and X belongs to V union T whole star. Now, this is an example where G equals to, where S is the variable, A and B are the terminals, S is the starting variable, and R is defined as the production rule. There is a finite set of production that represents the recursive definition of language where CFG have some production rules as the first rule is it has a single variable that is being defined to the left of the production. Second, it has a production symbol, and third has a string of 0 or more terminals. Okay, like here is the S, a single variable, deriving symbol, and the rest is the grammar, that is a terminal, non-terminal, and again a terminal. Okay, here are some examples that S derives SS and S derives single epsilon. Now this grammar generates strings such as ABAB, AAA, BBB, and AAB, ABB with the help of these three production rules. Okay. Now the application of context-free grammar is, the first one is CFG are applied in parser, extract the meaning of program prior to generating the compiled code of performing the interpreted execution design. The second is, it is easy to visualize derivation in CFG as it can be represented using trees. The third is, they are also used in describing syntax of programming language. And the fourth is structure of documents, example XML. Now our topic is normal forms. Okay, there are two normal forms, CNF and GNF. The first, CNF, Chomsky normal form. A context-free grammar is said to be in Chomsky normal form if every production is of the form given below, where NT stands for non-terminal and T stands for terminal. The production or the rules in the CNF is that a non-terminal should derive two non-terminals, or a non-terminal should derive a single terminal. Here is an example where S is a non-terminals deriving A and B, they both are non-terminals. Or example is the S non-terminals derives a single terminal. Okay. In CNF, the length of the right side can be either two non-terminals or a single terminal, but in GNF we have as many as length or on the right hand side followed by a single terminal. That means in CNF it is restriction on the length on the right side of the production that it should be either of two non-terminals or a single terminal. Whereas in GNF there are no such restriction, only one restriction, that on the right hand side at very first a terminal should come and then followed by as many as non-terminals or terminals. The definition of GNF is, a context-free grammar is said to be Grebec normal form if all the production have the form that is A deriving AX, where A is a non-terminal, this is production symbol, and A is a terminal and followed by anything x. Okay, where A belongs to terminal and x be any variable. Now conversion of CFG into CNF. The very first rule is eliminate the unit productions and null productions if any. This removal of unit production and null production will be showed you in the description below link. The second is eliminate the terminus on the right hand side of the length 2 or more. And the third rule is restrict the number of variables on the right hand side of production of 2. Okay, here is S, a non-terminal deriving 3 non-terminals, a single terminal and terminal, non-terminal, and A derives B, both are non-terminals, or S and B deriving a single terminal or epsilon. Now with the help of this example we will see that how to convert from CFG to CNF. Okay, conversion of CFG into CNF. Since S appears in right hand side in the question, we add a new state S0 that S0 such should derive S. Okay, so now here S0 is deriving S, and the same as the question that S deriving 3 non-terminals and the rest the such. The second is after removing unit and null production, the production set becomes S0 deriving 3 non-terminals and the rest as it is. Okay, now we will find out more than 2 variables in RHS because it is a restriction in CNF that on the right hand side only 2 non-terminals should come. But here in the answer we are giving here S0 deriving 3 non-terminals, S deriving 3 non-terminals, and again A deriving 3 non-terminals. So these are violating our CNF. Now we have to remove this. So what we have done here, S0 was deriving ASA. So in place of SA we are substituting X. So now our productions become S0 derives AX. Now as non-terminal is deriving 2 non-terminals. So this is done in CNF. Okay, the rest is done the same. Now we have to change the production, like in CNF it is showing that a non-terminal should derive a single terminal, but here it is a terminal as well as a non-terminal, so we have to remove this non-terminal. So what we have done, we have in place of A we write Y, we substitute A with the Y. So here our productions become S0 derives X, this one, and YB, this. Substituting in place of A we have placed Y. So this now becomes a non-terminal deriving 2 non-terminals. So this is acceptable in CNF. So we have hence done our question in CNF. The rest is as it is, similar in the similar way. Now this is a CFG conversion into GNF. Okay, GNF has restriction that in the first of the right production, the very first element or a variable should be a terminal, and the rest can be anything non-terminal or terminal. So with the help of a question we will understand these rules. Okay, this is an example where S equals to AB, a non-terminal and terminal, A derives AS, a terminal and a non-terminal, and third is A derives a single terminal. So what we will do, the very first step is change the name of non-terminal symbols to AI. This is S, so we are changing this S to the name A1 and this A to the A2. This again A to A2, S again to A1, and the rest as it is, A to A2. Okay, now the second step is that we have changed the name of non-terminals, but we have to also change the names of terminals. So here B is changed to A3 and A is changed to A4. Here it is showing A3 deriving B and A4 deriving A. The third step is The modify the rules so that the non-terminals are in the ascending order. By ascending order we mean that in GNF the left of the production symbol should be lower value than the than the right hand side. Okay, like here this is given A1 deriving A2 A3. So here the A1 is having lower value than A2 A3. Okay, so in example, no such error was there. So what now we will do? We will start substituting the values. So here A4 was A, A3 was B, A2 was A. So here A2 was deriving A4 A1 where A4 is A. So here we substitute the value of A4. So A2 becomes deriving A1. Now again A1 was deriving A2 A3, so substituting the value of A2, A1 becomes A1 A3. So now this is our required GNF form where it starts on the right hand side, it starts with the A, which is a terminal, and followed by non-terminals. This okay, A2 deriving A1 where it is starting with the terminal and non-terminal, it is also acceptable. Now A2 deriving A, this is only a single terminal which is also acceptable in GNF. The similar way A3 derives B and A4 derives A are also acceptable in GNF form. Now we will understand as one more case, that is a left recursive case occurs while converting CNF to GNF. Okay, it is that the variable on the left hand side of the production is and the very next right hand side of the production should be same, like here it is A2 and deriving symbol, and is here again A2. One more example, that A deriving AB where here also A and here also A, so these both are A, that both are equal, so a lemma condition is to be added over here. So it is there that A deriving A alpha 1 or A alpha 2 or beta 1 or beta 2. These are the production rules. Now A will be deriving beta 1 Z or beta 2 Z. A again deriving beta 1 beta 2, or Z deriving alpha 1 or alpha 2, and again Z deriving alpha 1 Z and alpha 2 Z. The substitute Z in the grammar, so we get the required GNF form. This should be substituted on the required to obtain the required GNF form. Now the application of normal forms are simplicity of proofs enables parsing. CNF enables polynomial time algorithm to decide whether a string can be generated by a grammar. GNF is used in Schmidt's theorem, which tells us that every CFL is essentially a language whose number are string of balanced parentheses. As he invented GNF, Tom proved that every CFG can be recognized by a PDA, that is push down automata, that works in real time without epsilon transition. Okay, thank you.